Okay, so while I know we're doing mainly dynamics of energy right now, this seemed important for what y'all are doing, so I want to explain it really quickly. Basically, it's 3A1. It's one of the first ones under kinematics. An observer in a particular reference frame can describe the motion of an object using quantities, remember measurable quantities, such as position, displacement, distance, velocity, speed, and acceleration. And notice this, it says displacement, velocity, and acceleration are all vector quantities. And if you remember, that means they have both magnitude, an amount, and direction, which they point in a certain way, like vector goes fishing. So keep that in mind. That means that position, distance, and speed are scalar quantities. So that means they just have magnitude. So like magnitude only, just an amount. So, okay, now here's the important part. First of all, now these equations down here, I don't love the way they're written. So let me just get to what these actually are. Displacement is a change in position. So if you remember, change in is just delta. And position, think of position like a pirate's map. It's X. I don't like how they put the arrow over here. I don't care for that. Also remember that displacement, the symbol is S. It's like the third letter, and it has the vector arrow. And if you look at change in position, let's say you start here. That's your initial position. That's supposed to be dotted lines. Anyway, and you end up here like Energy Stadium. That's your final position. So if I want to know how much this is, I would subtract the initial from the final. So that is X final minus final position minus initial position. And you can define position as whatever you want. It's just most commonly done as X. If you have two dimensions, sometimes you'll see it as Y, but that's pretty much how you'll see that. Okay, this next one, velocity is the rate of change of position with time. If you remember, like miles per hour, meters per second, it is your displacement, that's an arrow, over time. That is velocity. And if you will recall, velocity is a vector. It's like speed with a direction. Okay, another way to write this that you might see, and it might be more useful as we go on, is remember, displacement is a change in position, but delta, change in position, over change in time. As you get more advanced in math, what you'll see is if you see something rate of change, it's usually change in something over change in time. If you see the words rate of change, like in a pre-cal class or calculus class. Okay, and then you have acceleration is the rate of change of velocity with time. So, if you heard what I said earlier, basically acceleration, and it is a vector. It's force's best friend. They always go the same, or net force's best friend. They always do the same thing, go the same way. So acceleration is actually, see how it says the rate of change? That's going to mean change in something over change in time, and rate of change of velocity with time. So that's supposed to be an arrow. So that's what acceleration is. So just kind of knowing what these are. Now let's talk about the relationships they have with each other, which is the part you really need to know. Okay, so as we said, velocity is equal to displacement over time, just a simple way. So therefore, sorry, it's kind of hard to write on this. Actually, what I want to do is I want to solve this for displacement. So the way I would do that, it's like this, velocity over 1. This means divide, this means multiply. So if I want to solve this for S, for your displacement, that means I'm going to put the T on top, time, just multiply this by time. So therefore, displacement equals velocity times time. And I'm kind of giving you a little bit of a clue for something later on this week. So anyway, displacement, so therefore, see, you can put all these over 1 if you want to make them a fraction. You absolutely don't have to do that. I'm just doing that because my handwriting's messy. So therefore, displacement is directly proportional to velocity. That means the greater the velocity, the further the object will go. Makes sense. If you have 2 cars driving for an hour, if one's going 30 and one's going 60, which one's going to go further? Okay, and this also means, I'll put and, displacement is directly proportional to time. So that means if you drive for an hour versus 30 minutes going at a constant speed, you're going to go further if you drive an hour. It's kind of obvious, but I just thought I would point that out. This also might be useful if you're thinking about, especially maybe this part, if you're thinking about how long your string needs to be in the balloon challenge thing. Hope this helps.